power series video. I am Nadav, and today we will be explaining what a power series is and what it can be used for. Alright, so we have power series being defined as a series from n equals 0 to infinity as a sub n times x minus a is raised to the nth power. For a power series to converge, there can only be three possibilities. One of those possibilities is that a series converges only at c, and that's when the radius of convergence is equal to 0. Another possibility is that there exists a real number such that r equals greater than 0 such that the series converges as the absolute value of x minus c is less than r, and it diverges when x minus c, the absolute value of that, is greater than r. And the third possibility is that the series converges for all real numbers such that the radius is equal to infinity, that being negative infinity to positive infinity. So how do we find the radius of convergence? Well, we use the ratio test to help us determine what the radius and interval of convergence is.
Okay, so now we're going to do a practice problem, and it's 2n over n times 4x minus 8 to the n. Okay, so the first step in order to find our radius and interval of convergence is to do the ratio test. So here we do 2 to the n plus 1 times 4x minus 8 to the n plus 1 over n plus 1 times the original function. And then we're going to go ahead and simplify and cancel out some terms. Alright, so now that we simplified, we get 2n times 4x minus 8 over n plus 1. But here you can see that we can take this out, and then we get the limit of this, which, because the exponents are equal, is going to equal the coefficient here, so it's going to equal 2. Okay, so now that we've simplified, we get 2 times the absolute value of 4x minus 8. And then now we have to find the interval of convergence. And the rules say that series converges when it is smaller than 1. So now you have to simplify that and get our interval of convergence. Okay, so now we simplify, we factor out the 4, and we get 8 times the absolute value of x minus 2 is smaller than 1. And then we divide both sides by 8, and we get that our radius of convergence is 1/8. But now we have to find our interval of convergence, so we just simplify and we get that x has to be greater than 15 over 8 and smaller than 17 over 8, and that's our interval of convergence. But now we have to check the endpoints to see if it includes those endpoints.
Okay, so now to check the endpoints, we have to plug in the x's back into the power series. So for the first one, x equals 15 over 8. We can plug them back in and we get an alternating series, and we find that it converges. And for x equals 17 over 8, we plug it back in and we get a p-series, and since the p is less or equal than 1, it diverges. So our interval of convergence is going to be 15 over 8 is less than or equal to x, which is less than 17 over 8, and the radius of convergence is 1/8.
Okay, so the second problem we're going to be doing is a series of n factorial times 2x plus 1 to the n. So the first step that we're going to do to find the interval of convergence for the series is we're going to use the ratio test. Okay. So after we did the ratio test and we canceled out everything, we ended up with the absolute value of 2x plus 1 times the limit as n approaches infinity of n plus 1.
Alright, so after taking the limit of n plus 1 as n approaches infinity, we get that the limit is equal to infinity. That means that the power series can only converge at a single point. When solving the power series, we find that it only converges when x is equal to negative 1 over 2. And since it only converges at a single point, the radius of convergence is equal to 0.
Hey everybody, it's Sam, and today we are going to do some calculus. Let's take a look. Alright, so right now we got a nice power series going on. I see the series notation. And to solve whether or not this converges or diverges at whatever, or if it's even conclusive, we need to simplify this a little bit. I see this n right here and then n right here, and I can deduct that I want to use a root test. So, when I take the limit, as n approaches infinity, of the nth root of this entire thing, to the n, oh, sorry, that's a little bit messy, but you can still read it. I cancel out all of my n's, right? So I get limit as n approaches infinity. This pretty much goes to the side. We don't have to worry about that right now. Limit as n approaches infinity, 1 over n. It's way easier. So we went from this to that using the root test. So the limit here equals 0. So what does that mean? 0 in our radius of in our root test is less than 1. So that means if it's less than 1, it converges. This series converges for all reals. It's a scenario. If it was greater than 1, it would diverge. But this is pretty easy. Calculus in about, what, say 2 minutes maybe? And the radius of convergence also here is infinity because we get our limit as 0. So, done for the day. 100 on the test.
Thank you for watching our Power Series video.